Okay. Okay, now we can start. Hello everyone, welcome to this webinar. Thank you for joining us. I'm Dmitry Ivanov, Professor for Supply Chain and Operations Management at Berlin School of Economics and Law. Thank you for joining, and also thank you for the anyLogistix company, especially to Ms. Daria Doroshenko for organizing this webinar. As I can see in the participant list, I see so many friends, so many people, colleagues, students whom I know and met at different conferences. And also I'm very happy to see new participants, and will be also happy to meet you in very near future at some conferences, and we hope that physical events will be organized very soon again. So, okay, let us start. I will try to share my screen with you so that you can see some slides which I prepared for this presentation today. So now I hope you can see the slides. Well, so the topic today is supply chain digital twins and resilience analysis. So basically we are going to look at the following agenda. I will start with some introductory knowledge about the ripple effect and resilience in supply chains. After that, we will reflect on the existing modeling in digital technology to manage resilience and risks in supply chains. A specific focus will be directed to the ripple effects which we have observed through the COVID-19 pandemic times. And after that, I would like to present current and future developments in the area of digital twins, the viable supply chain model, and reconfigurable supply chains. And finally, I would like to show you a short video where supply chain resilience has been modeled in anyLogistix. It is a new one. So some of you know the, say, more or less classical example from my transportation research paper on modeling of pandemic impacts on supply chains. It was the first paper. However, since so many people already know it, I thought that today it's better to show the new one, a new example of modeling food retail supply chain and its resilience through the pandemic times using anyLogistix. All right, so let us continue. And actually, you know, so increased interest in supply chain risks and resilience is usually born out of a crisis. Right? If we look a little bit in the past, in 1999, 2001, we had a lot of floods, then this terrorist attack, September 11 in New York City, many factory fires. And this launched a lot of attention into supply chain resilience. The next big step in this direction came from the world economic crisis in 2008, 2009, and followed by Fukushima, by tsunami and earthquake in Japan in 2011. That was probably one of the most prominent examples which motivated a lot of managers and a lot of researchers to study supply chain resilience. The most recent and the most prominent example is the COVID-19 pandemic, which has been a stress test for supply chain resilience, unveiling, in many cases, missing preparedness, insufficient recovery capabilities, and multiple ripple effects across different industries and sectors. So business and governments recognized an urgent need to review resilience of supply chains and enhance this resilience for future. And this is something what we are going to look at. I think the plan could be like in about 25-30 minutes, I will present some knowledge and recent developments, recent technology developments in this field. Then I will show you an example of how to model resilience in anyLogistix. And finally, we will have, I think, a quarter an hour, 10-15 minutes for a discussion. To start with supply chain resilience, it's the company's capability to withstand, adapt, and recover from disruptions to meet customer demand and ensure some target performance. Now, if we compare risk and resilience with, say, our immune systems and viruses, which we confront every day, one can say that risk, it's a kind of a virus, and resilience, it's an immune system of a supply chain, right? Responsible to absorb some not anticipated, not planned events from the environment, and in case if we have a disruption, in this case, resilience is responsible for recovery. Right? The same like with our immune systems. One specific area in supply chain resilience, it's named ripple effect. The ripple effect describes the disruption propagation in the supply chain network, leading to unavailability of components at different echelons in the supply chain and associated performance degradation. Right? In other words, some structural changes due to disruption frequently result in a decrease of some output of some supply chain KPIs like service level or annual revenues, and frequently we also observe deviations from the operations policies like production policy, inventory control policy, sourcing policy. To manage the ripple effect and disruptions in chain, we usually consider three major areas, which are measuring impact of disruption, performance impact, developing of stabilization actions, some policies to stabilize in the short term, and then preparing for mid-term and long-term recovery. In order to understand ripple effect better, I think most of you are familiar with the bullwhip effect. No, the bullwhip effect, it's a kind of operational risk or recurrent risk, which is characterized by high frequency and low impact, right? We would say impact on performance. Bullwhip effect is usually triggered by some small variation of demand, which amplifies when we are moving across different stages of the supply chain. Ripple effect considers different situation. It looks at exceptional or disruption risks, which are characterized by high performance impact and low frequency, right? So, and ripple effects is usually triggered by severe disruption in supply or in demand. Looking at the modeling and optimization, simulation techniques which we can observe to cope with the ripple effect and resilience analysis, we can classify three major areas. The first area is network and complexity theories. The second one is mathematical optimization, and the third one is simulation. Concrete methods are presented in this slide. So if you look at network theory, then such methods like Bayesian networks, reliability theory, Petri nets, Markov chains are usually used. Mathematical optimization usually looks at some location allocation problems and solutions to this problem using mixed integer linear programming. And when we introduce uncertainties, then it can be done with the help of robust optimization or with the help of stochastic models. Of course, there are also some other methods, like choice constraint optimization, fuzzy optimization, possibilistic models. All this it's in the scope of optimization. And then we also have simulation methods, right? So 3 major methods: agent-based simulation, discrete event simulation, and system dynamics. So this is what methodology, what modeling methodology can offer to cope with resilience and with the ripple effect. Now we are interested to see what are the managerial outcomes, what managers in real life can learn from application of this method. So, applying network level methods, we can identify disruption propagation scenarios of different severities, like pessimistic, optimistic ones. We can make stress testing of supply chain design, say structural design, to avoid disruption risk propagation. We can also identify critical suppliers and critical facilities in the network, which are of utmost importance for maintaining supply chain operations. And we can also analyze some adaptations of supply chain designs according to some changes in the environment of the system. Breaking down the discussion to the process level, usually mathematical optimization is applied. These methods are used for stress testing of supply chain production distribution plans within some predefined structural scenarios. It can also be used for analysis of contingency and preparedness plans and selection of recovery plans. And finally, if we look at control level, at the level of simulation, here and different simulation methods are usually used for analysis of disruption propagation in dynamics. When we include some time-dependent components with consideration of detailed production and inventory control policies. And simulation also allows us to understand operational policies during the disruption, in transition to recovery, and during the recovery periods. During the COVID-19 pandemic, we have seen a lot of the ripple effect. The ripple effect has actually been one of the strongest stressors on supply chain resilience during the pandemic. If we follow the classification of the World Health Organization, each pandemic has 5 major stages, which are anticipation, early detection, containment, control and mitigation, and elimination. So I do really hope that we all, in all countries in our world, will reach the last stage, the elimination stage, very soon. Now it looks like in most countries we are at the stage of control and mitigation. From the beginning, we have seen first ripple effects, say, in January 2020, when suppliers and factories in China stopped working. Then we have seen subsequent closure of ports in February 2020 and associated propagation of these disruptions to the OEMs in Europe and in the North America in March and April 2020. So a classical ripple effect. We have also seen a lot of ripple effects associated with, as we say, deep uncertainty during the pandemic. The prominent example is the current semiconductor shortage, which started in December 2020, and the first ripple effects of this event have been observed already in January 2021. Now in September 2021, looking back at the last 9 months of this year, we see that supply chain management becomes more and more difficult. On one hand, we have semiconductor shortage. On the other hand, we have inflation, beginning inflation, price increase, especially for energy. We have seen a lot of fluctuations on the transportation market, resulted in highly increased transportation costs. So on one hand, we have fluctuations of demand, we have fluctuations of supply, of logistics. This is something which actually supply chain managers have not seen for the last 2-3 decades and creates a lot of challenges. We can also expect, it's now looking back at the time when we will exit the pandemic, we can also expect some delayed and say inertia effects mostly caused by production capacity shutdowns during the pandemic, and also the events which come from shortage of supply and difficulties in forecasting demand. Also, with consideration of price fluctuations and incoming inflation. So here one can expect even some product deficits and price increases in the markets, which we actually already observe now, and this trend can be continued, say, for the last 1-2 years. What to do? So, enough of stressors for supply chains, how we can adapt strategies to cope with such situations. In one of my recent IGPR papers, I tried to develop some generalized perspectives, and I came up with 4 major adaptation strategies which supply chains have used during the COVID-19 pandemic. These strategies are also associated with 3 levels of the viable supply chain: the ecosystem level, the network level, and the resources level. So the first strategy is intertwining, right? It is related to the ecosystem level. The most prominent example of intertwining is when, in the wake of the pandemic, industrial supply chains started producing healthcare products, intertwining with commercial supply chains. Right? So say 2 different ecosystems intertwined, supply chains of 2 different ecosystems intertwined with each other. The second strategy is substitution, which is related to the network structural reconfiguration or product substitution if we look at the resources. Most prominent example of substitution at the network level is backup supplier, when we replace one supplier by another one. Or if we break down discussion to the resource level, here we can substitute one product by another one to survive through the pandemic. Scalability is the next adaptation strategy. Most prominent example is e-commerce. Take Amazon. At the beginning of the pandemic, Amazon significantly increased the logistics capacities due to very high demand, right? And this is what we name network size scalability. Or if you look at the resource level, say the manufacturing system level, then capacity expansion can be considered as scalability. And finally, repurposing, right? So this is something where what we all have seen, where car manufacturers repurpose their production and started producing face shields or ventilators, or also other firms which were specialized on expensive perfumes started producing hand sanitizers. And this is something what we relate to process flexibility at the network level and product flexibility at the level of resources. One interesting observation is that through the pandemic, supply chain management understanding and actually paradigm of supply chain management has changed. The supply chains, as we know them now, have been designed, say, for about 2 decades, I say 20 years ago. These were times of, say, relative stability in demand and supply, and this stability led to the formation, say, of a crisis-free mentality in the minds of most of the supply chains. Also, education, also what we educated in our courses was mostly based on a kind of stable situation. Right? We considered some random uncertainty fluctuations of demand, of lead time. However, no one could imagine that something like pandemic and something like what we see now in energy sector, inflation, can come, right? So, and these previous concepts were based on beliefs that we have risk and uncertainty under control, that we can make long-term planning. The results of this were, say, rigid, lean network structures and planning paradigms. And all this was turned upside down during the COVID-19 pandemic, which challenged supply chain management by introducing a novel context of order and chaos, controllable and uncontrollable, rigid and fluid, fixed and adaptable, certain and uncertain. Right? So during the pandemic, we have seen that the paradigm changed from, say, long-term planning to continuous preparedness for disruption and living in anticipation of disruptions. Right? So kind of adaptation to ever-changing environments, situational reactions, short-term planning horizons. This is something what is characteristic for supply chain management now. And we can say the only certainty is that everything is uncertain. So more or less, in the pre-pandemic supply chain management, disruptions have been considered as exceptional events. And what we see now, and this is something what is a paradigm change, the crisis is considered as a normal. Such considerations lead us to rethinking and reinventing supply chain management. Right? So supply chain is exposed to a lot of dynamics from very different parts, from business, which offers more and more digital technology, platforms, economies, from nature, climate change, epidemic, pandemics, natural disasters, from the governments, and also sustainable developments, green economies, pandemic control measures. All this creates huge constraints and challenges for supply chain management, and also from the markets. Right? So financial crisis, inflations, and also digital platforms as a completely new form of supply chain management. This is something what cannot be addressed fully considering classical supply chain management paradigm. Here we can ask some questions which are not trivial, and I'm afraid I do not have good answers to them now. So just to motivate some thinking, some discussion, some debate in this area. So say, what is the role of adaptability in resilience and viability of supply chains, and how to implement adaptability while still maintaining profitability, right? And cost efficiency. Another question can be, should we change from long-term planning to situational reaction paradigm, or can we control uncontrollable? Right? And is planning under chaotic conditions helpful and counterproductive? All right. So now let us turn to technological part. One of the central capabilities to improve resilience is visibility. I would say building end-to-end visibility can improve resilience. And we can build end-to-end visibility by transition from offline modeling to online data-driven digital twins. And so what is digital twins? It's a kind of computerized supply chain model, digital supply chain model, which at each point of time, ideally at each point of time, right, represents the physical supply chain with all the relevant data like transportation, inventory, demand, and capacity data. Such a tool, of course, is of high value for planning and real-time control decisions. In my opinion, anyLogistix is a digital supply chain tool. Right? It contains, with the help of anyLogistix, you can describe the whole supply chain. You can describe the downstream part, demand, customers, distribution centers. You can also describe your own manufacturing, and you describe the upstream supplies and associated logistics. This is something actually where we can describe our whole supply chain. And with that, so the anyLogistix is a kind of supply chain model in a digital space. And moreover, we can use this, in this model, yes, we can represent firms of the physical supply chain, associated flows between these firms, and data related to different parts of the supply chain. And moreover, it is not, say, a passive digital twin. It is an active digital twin with the help of network optimization, with the help of simulation, and with the help of performance analysis. We can use this data with the help of different analytics to support decision making in all of the areas of supply chain management, in the network design, in the master planning, in inventory control, and so on and so on. In order to make this, say, offline digital twin to be a real-time digital twin, of course, we need to connect the available databases, simulation, optimization model with some external system. Like, and if we use example of resilience, different data about disruptions can come from external systems, put as, say, parameters of constraints in network optimization or as events in dynamic simulations. So every time when we start optimization simulations, the model starts with updated parameters, and the results can be put to some ERP systems or BI systems for more advanced performance analysis. So this is just an example of how we can use such a digital twin for stress test and review of supply chain resilience. In anyLogistix, we built our supply chain model. Some risk data are coming from external systems, then we can see if our supply chains is affected by these disruption risks, and if yes, we can make stress testing of our supply chain design, select a recovery plan, and also perform advanced performance analysis of this potential or real impacts of disruptions. Now let us start with the last topic what I would like to consider today. It is what have we learned? What did we learn through the pandemic times, and how should we improve in future? One major concept which can be developed is viability, right? So viable supply chain. The COVID-19 pandemic actually laid out a set of completely novel decision-making situations that go beyond our classical understanding of resilience. And here viability can be introduced. It is the ability of a supply chain to maintain itself and survive in a changing environment through the redesign of structures and replanning of performance with long-term impacts. Recall, resilience is ability to return, to bounce back to the initial state. Right? And viability is a general ability to survive. And survivability is ability to continue to exist and secure provision of society with products, services of vital needs by adapting network designs and functions to radically change environment. The viable supply chain model, which I developed in 2020, here you can see the reference for this paper. It's based on three major supply chain designs and adaptation mechanisms between these designs. These designs are lean or agile, resilient, and survivable. Right? So, lean supply chain design, it's used at the time of growth, at the time of prosperity, when economies grows, when we have stable situation, we should make most of the cost efficiency and responsiveness to get higher profits. Resilient supply chain design is supposed to absorb and recover from disruptions which are considered as singular events, like earthquake, tsunami, fire, strike. Here, classical resilience capabilities like risk inventory, capacity buffers, or backup supplies are used. And then we add survivable supply chain design, which is used at the times of super disruptions, like a global pandemic, for example, where we need to make production repurposing, localization of supply base, redesign of supply and logistics. And ideally, each supply chain should have these three designs and be able to switch, to adapt between them depending on the situation which we have. In order to clarify the difference between resilience and viability, I would like to show this slide. This comes from another paper where we conceptualize viability empirically. And basically you can see the difference, right? Supply chain resilience is a kind of bouncing back to old normal once disrupted to recover plant performance. However, bouncing back to old normal is not always possible, and especially in case of super disruption and substantial structural changes, we cannot return to old normal. The only way is to search for and adapt to new normal, right? And then stabilize in this new normal and develop some recovery plans. I think this is something what makes viability different, but also close in some sense to resilience. Another important issue is intertwined supply networks. As we have seen, resilience of individual supply chains is important. However, supply chains are usually interconnecting and intersect with other supply chains. Like, for example, suppliers in the automotive sectors are at the same time producers of valves for respirators and healthcare. Right? So the same company can be buyer and supplier at the same time in different ecosystems, right? And as such, it is important to develop methods and to models, not only to analyze resilience of individual supply chains, but to analyze viability of the ecosystems, of the intertwined supply networks. And this is something what we named reconfigurable supply chain based on the theory of multi-structural systems, structural dynamics control. Here we can review supply chains as multi-structural systems which are composed, of course, of a network of suppliers, factories, and distribution centers. But we also introduce other structures like technology structure, logistics structure, financial structure, like inflation. Inflation is a huge disruption for the supply chain, and disruption in financial structure has direct impact on organizational structure, so on logistics structure, on process structure. So the same in information structure, cyber attacks, cyber risks, cyber resilience. This is something what becomes more and more important considering the growing importance of digital technology in the supply chain. All right, so this is something what I wanted to share with you regarding theoretical aspects. Now I would actually like to start with the video of how to model resilience using anyLogistix. This is an example for food retail supply chain network where we started different scenarios and analyzed different impacts of pandemic on the supply chain. Now let me just, yes, I think this is this one. Well, now let us consider disruption modeling in anyLogistix. Our supply chain is comprised of suppliers, which are marked here as yellow icons, 3 distribution centers, these red icons, and customers, the blue icons, right? The material flows are organized in the way that suppliers deliver to distribution centers and distribution centers to customers. We associate some transportation cost for this process and also define some shipment rules. In our case, LTL, shipment control policy. For customers, demand should be determined for simulation experiments. Here we associate some daily demand quantity for each product group for each customer. In total, we have 10 product groups with associated units, selling prices, and costs. Finally, we should define operational control policies, right? Inventory control policy is in our case order up to level policy, so min and max policy with reorder point and target inventory parameters. which are defined for each DC and for each product group. In process, we define transportation costs. In shipping, transportation control policy. And we also have to define sourcing. Right. And with that data, we can first run simulation for business as usual scenario. In this scenario, no disruptions are considered. The objective of the simulation is to observe how the firm is performing in a business as usual situation, to observe our, say, normal supply chain performance. So here we can see simulations. These purple points are trucks which are moving our supply chain, and we can observe performance of our supply chain according to different KPIs. And so speeding up a little bit our simulation, we can see that in a business usual scenario, supply chain operates very good, on-time delivery 100%, no late orders, lead time at maximum half a day, and very stable inventory dynamic, right? Transportation, we can see number of vehicles, number of trucks utilized per year in the supply chain, associated transportation costs, the total travel distance, and how many items have been shipped. So, and of course we can also see our major financial KPIs, so revenues which we are doing, profits, and so on. All right, now we introduce our first disruption scenario, which will be demand increase. We associate some demand coefficients to each of the 4 periods according to our pandemic scenario, right? A drastic demand increase during the first pandemic wave, then a stabilization in summer, and another increase during the second wave. And now we are running this simulation, and here we can see impact of disruption on the supply chain performance because of demand increase and no adaptation in inventory control for this time. We have negative impact on on-time delivery. Our lead times increased. We have late orders, and we also have destabilized inventory behaviors. We can observe here in the diagram. So especially during the first pandemic wave, here in the demand product backlog diagrams, we can observe increase in backlog, which it subsequently decreased during the summer months. However, in the wake of the second wave on the pandemic, we again see increase in the backlog, and obviously we are doing not as good as in the business as usual scenario, right? Looking at the shutdown in supplier factories, we define this shutdown as events. We can see the shutdown in 3 suppliers, subject to different periods, especially during the first wave of the pandemic, right? Each disruption has 2 events, temporarily closed and open, and associated dates. Well, looking at this scenario, we can observe that impact on on-time delivery it's lower as in the case of surges in demand. And we also can eliminate backlog. Well, okay, here we do not consider supply disruptions through the second wave of pandemic. That's why we don't have any new additional backlog through the second wave of the pandemic. So, and this is an interesting tool, now to compare the impact of different disruptions on the supply chain. So, okay, now I think you've got a kind of understanding. You've got a kind of understanding what happens in anyLogistix when we model, when we simulate different disruption scenarios, like COVID, but also different other scenarios can be simulated, and resilience of supply chains can be analyzed with consideration of different uncertainties in demand and supply in logistics, whatever we consider, right? Okay, so now I think we can start with your questions, but before closing, I would like to draw your attentions to two upcoming workshops which I will conduct. And the first one will be on October 30th, 31st. It is a kind of introductory academic workshops where I basically explain usage of supply chain, of anyLogistix in supply chain operations management, teaching and learning, how to use anyLogistix in teaching and making research and learning a supply chain. And on November 27, 28, it will be advanced academic workshop where we will look much more detailed during 2 days at the topics which we briefly considered today: how to build digital twins, what is a combination of artificial intelligence and simulation optimization, and also from consulting point of view, also from researchers point of view, how to do projects using anyLogistix, both consulting and research project, and also teaching projects. So if you are interested, you can register at using anyLogistix website as you did for this workshop. And if you are interested in supply chain resilience at my school, Berlin School of Economics and Law, I will provide a 5-day, 20 academic hours course, online course, open for everyone, which will start on 11th of November and go till 9th of December, running from 2 to 5:15 p.m. Central European Time, where we will consider all possible topics around supply chain resilience, starting from the classical supply chain capabilities and looking also at the COVID-19 pandemic times from different perspectives: management perspective, modeling, and technology perspective. All right, we are good in time. As I promised, after 45 minutes, I will stop. I thank you very much for your attention. And now I really open to your questions. I see